come up in about a second. Some people are coming in the room. That's good. Let me know when you see the Facebook thing live.
Yeah, I'm refreshing to see.
It's taking an awful long time.
Yes.
I see some familiar names on the attendee list. How exciting.
Oh, yeah, me too. And John Harris says hello. I see him in the chat window. And, oh, who's that? Owen Newton says hi. Rich is here. Cool.
There's got my chat window back.
There we go.
I don't know if the Facebook is getting launched or not. I still have the spinning wheel here.
Yeah, it's not showing.
Maybe I should try to restart that.
I know I would. And I don't have those options anymore. Only you do. It says it's live on Facebook.
We'll give this another try. Oh, it does?
Yeah, it says it up in my screen.
Okay.
Are you on Newsfeed or Blockly?
Should be on the Blockly group. To our attendees who are coming into the room right now, you can talk anytime or you can type. If you want to put on a headset, feel free. You just have to click on your name and raise your hand. But I think what we could probably do, since there are reasonable numbers, once we enable you, we'll just leave your microphone on. Lots of familiar faces. We got Brian. I think we recognize most of these names. David Francis, Gary, John, another John, yep. Some teachers. Lawrence LeBranch, who may be sharing a project with us, and of course, Rich.
Yeah.
So we'll get started in about 1 minute for everybody.
What's your Facebook icon doing, Ken?
Let's go give it a look.
Still?
I don't think it showed up.
Yeah, I'm not seeing it.
Well,
interesting.
And the option to restart it is null and void.
Yeah.
So.
Oh no.
Oh well.
Yeah. It says it's so interesting. It does say it's live on Facebook though. So.
Good enough. Well, what do you say we get started on this adventure?
Let's go for it.
All right. Welcome to the BlocklyProp for Hobbyists and Makers webinar. I'm Ken Gracie, and I'll be your host today. This webinar is very informal, and it's really for you. I know that when I sit through many webinars, I just sometimes ask myself, gosh, I wish the host would just answer this question or get to this point. So I want to encourage all of you to type questions or raise your hand and ask them. You are part of us, and we really love it when you press us with different questions too. And because of that, I have three extra smart people with me today. One is Kate Hay, who keeps our webinar rolling. Thanks, Kate.
Hello.
And Jeff Martin, who's been with Parallax for 20 plus years, has done every possible job. And Carol Hazlitt, who I will introduce in more detail in just a minute. So let's get started. We have about 45 minutes today. This webinar will be recorded and put on YouTube and hopefully on Facebook too.
Yeah.
So about the controls first, how to use this tool. Every time we log in, this tool looks a little bit different, but basically you'll see on a black control bar Q&A where you can type in questions and we'll answer them, or you can raise your hand on the participants window and then we will enable your microphone. So there's also a chat and you can interact with us any way you'd like. This is what we're talking about today. I'll give you a high-speed introduction to Parallax. We just have a variety of people are present. Some of them, it's a first-time visit to us, and for others, they're just like, would you just get to the project? Show me the spooky doll. So, quick introduction, and then we will show you half a dozen BlocklyProp projects. And through this, we will show you also how to get started with BlocklyProp. And we'll likely cover a few of the things BlocklyProp can't do and we would like it to do in the future. But it has become a very powerful tool for all of us. And this is our special guest today. This is Carol Hazlitt. Her video's on. Hi, Carol. Oh, she's going to unmute herself and say hi.
Hi, hello.
And Carol Hazlitt has retired from the phone company as an engineer up in the Seattle area and as an electrician, right, Carol?
Yeah.
Okay, yeah, and she's been building robots since 1985, and she's very prominently involved with Robothon and Seattle Robotics Society next month. And she'll be sharing a couple of her BlocklyProp projects today. Thanks, Carol, for coming.
Oh, thank you.
We're so glad you're here.
Now look at how much younger I looked when I was holding the Elevate.
That was yesterday. This is a Parallax team. If you haven't met us, come into Rockland and you can talk to all these people. And you can also call us on the phone anytime. We are building products and answering your calls in Rockland. In short, this is what we're about. Robots, we design our own chips. We make tutorials and assessment material for schools. We're largely about electronics. We like to see every student building and programming with our products. And we train an awful lot of teachers. We trained over 500 last year, and it's very possible we'll hit the same number this year. Our manufacturing and the star of the show, BlocklyProp. So what we've done is we have combined a very capable multi-core microcontroller with a very fun, cartoonish-looking visual programming language called Blockly. And this has been customized to work very effectively with our chip, as we'll show you. So there's some features that really bring out the best of our propeller processor in one block. This chip is also programmable in Spin, Assembly, C, and what's so unique about it is it has 8 processors in one with shared memory. So sooner or later, once you get into programming, you find out that, I need to do 2 things at once. How do I pulse a servo, get some serial data, drive a display, and then keep track of all the time? So this doesn't become much of a problem, you know, when we're making pumpkins glow and things like that, but it does pretty quick. And it depends what you're connecting your microcontroller. And I'll show you an example today with my visual metronome that really relied on the architecture of the propeller. And for the real geeks and engineers, here's our block diagram. This is all over the internet, so we won't spend any time here unless Jeff wants to say anything. All right, I think this is your drawing, Jeff.
Yep. I had a lot to do with that, yes.
That's a career piece of artwork from you.
You do the drawings?
I signed it.
You do the drawings, Jeff?
No, I actually worked with somebody else that was doing the drawing, but I did a significant part of rearranging things and deciding how we should describe certain components.
I'd like to get a picture of the breadboard and everything with no
Nothing on
writing
it.
or design. Yeah, nothing on it, so that I can use it over and over again to do some of the stuff I want to write. put my own.
We have these in Corel Draw formats, and we can do that for you.
Email them.
Yeah.
Email
And this is the,
them tonight.
yeah, we can do it for today. Andy has made that drawing about 100,000 times by now. So here's a quick look at the propeller activity board. In general, Parallax products are not stackable with shields, and we give you breadboard space. We like to have people work with electronics and components. So our boards tend to have everything on them that people generally would want to use. Like in the upper right-hand corner, these are all ports for servos and sensors. And on the left side, that's a socket for RF devices and SD cards, so you can put sounds on them or communicate wirelessly. There's a programming port, and there's a stereo output on the bottom, which goes to amplifiers. There's an A to D converter, a couple LEDs, and a very handy power switch. So if you're interested in that, check out the docs for it. So to get started, how many newbies do we have to BlocklyProp here today? And would it help if we showed you the programming of a quick project? Maybe you can type in the chat window, because I always kind of want to see the tools that people are talking about. Oh, can I see? Okay, good idea. All right, so I got their attention. All right, so let's just do that. Here's what I have. We'll spend about 5 or 6 minutes on this in particular. So I switched my video over to the circuit, and when you look at these videos, they're arranged probably in squares or in a row, depending on how you have your display set up. But you could click on some icons on top and make the circuit one large if you'd like. So go ahead and do that. And then you could see the circuit as we proceed with a little bit of coding. And the circuit we have is a ping sensor, which is an ultrasonic sensor, and then there's a speaker and a couple of LEDs. So let's just jump over to Blockly. And if everything is still working right with all the USB unplugs and plugs I've done today. Yep, looks like my port is still there. Okay, so I'll give this a little bit of a zoom for you. There we go. This is a BlocklyProp workspace, and this runs on your browser, but the data comes from our Amazon web servers. So there's no updating of your software. Every time you go here, there might be some new surprises showing up. So it's always current. And what we'd like to do with this little circuit is we want to get some data from this ping first, and then we're going to make a theremin. So we will use the distance from our hand going up and down to make some sound on the speaker. It's just a real simple input-output project. So with most everything we do, there's a repeat loop there because programs start over. And we would like to go get the sensor. As I do that, I want to draw your attention to all the things in this list. So these are all sensors that Parallax makes, and we've boiled the communication down to 1 or 2 blocks usually for these sensors. Now, don't worry if you don't see what you want to use here, because we have protocols for communication, pulse measurement, for analog input, and most things you want to do. Okay, there are certain things you won't probably be doing, but if you're like me, it might take you 20 years to get to that stage. So this ping sensor I have is on pin 12. And this is keyed to connect to a variable, so we will go ahead and get one. By default, BlocklyProp calls everything item, and you can just click on that and then rename it or call it a new variable. And I'm going to call it distance cm. Okay, so now every time this line of code is encountered, it will go out to the ping, get the distance, store it in that variable. So what do we do with this? Let's display it. So we will go into communicate, and we'll find a block for graphing. And there are 2 of them. And one of them is an initialize block, and the other one is the actual graphing block. And it has this label here, so you can put distance on there. And then you can put the variable right here. So we could have actually done this, but, well, we decided not to. So we'll just grab that. And I like to put a little bit of a pause in here so things don't get overwhelmed. And let's just download this and see what happens. This is when things sometimes blow up. Right, Jeff?
Yes. Like
On my Mac, at least. I'd be really surprised if that doesn't work.
Should have
Very
responded by now.
strange. Yeah. Okay, no problem. We will just try that again. Unplug the board. Go through some typical troubleshooting. Just before this webinar, Kate and I were plugging every possible thing into my computer. And my Mac, after a while, throws its arms up and says it's had enough. Okay.
Just the demo gods.
The only time this doesn't work is when we're doing something live. But that's okay. Let's just see. Make sure that the BlocklyProp client is running.
You can unplug it and then just leave it unplugged until that port disappears. Let's make sure that part's working.
Yeah, so it didn't. So maybe we'll actually just grab start a new window and see if that does it.
Or get a real computer like an IBM.
Oh, it is time. Don't make fun of me. Set up a new project. And I'll plug this in. Let's see if it shows up.
Still looking for your BlocklyProp client.
Okay. All right. So everyone sit tight for a moment. Power's good. I got the USB power. So let's just see if BlocklyProp client is running. Everyone sit tight for a minute.
So just so everybody knows, the things are changing, but when we created this, the state of technology was that anything web-based could not access hardware serial ports for good reason. And so since it's a web-based editor, we had to create a little application that sits on the computer that can communicate between the browser and the propeller that's connected to the computer. And that's what the BlocklyProp client is.
I'm just restarting it now.
And then try refreshing your browser.
All right.
There we go.
Okay.
It looked like it had just connected. There we go. Yeah. Let's see if the download works.
All right. So yeah, we'll just do a simple download just to see that all is good. Okay. Not sure what happened there. Okay. So where were we? We lost 2 minutes. Sorry for those that are so patiently waited around. Okay. So we were starting out to set up the sensor. So we'll do that again. And we'll grab a variable block. We'll rename it. And let's plop that in here. And then we'll get a graphing block. And attach the variable to that. And we're going to test these things just one step at a time to make sure everything works too. And a little bit of a delay.
One of the things I like best about BlocklyProp is when I'm trying to get a program to work, it's so much easier to change the coding all around into different ways and different configurations than when you're trying to program in C, straight out. And you don't have to worry about all the brackets and parentheses and semicolons.
Okay, who's going to find the error in my program and receive the free animation kit? No one's pointing out the bugs. That was it, pin 12. We'll try again. I'm going to have to keep all those animations to myself. Oh, it says item. All right. Okay.
Yeah,
we have our team.
Oh, look at that. Yeah.
They are here. Good catch, everybody. We'll just turn and burn on our BlocklyProp code here. Okay. So yeah, it seems to work. I'm just kind of raising my hand above it. So let's use that as an output to the speaker. And then very quickly, we're going to throw a couple of LEDs in there. I just want to show you the new processor block before we move on, because this is something that's so unique to the propeller. Down under audio, we will get the frequency out block. And the speaker is on pin 27, so we'll go ahead and turn it on. And we'll make a, let's say, a 10 millisecond sound. And we want the frequency to be the distance to my hand. So we'll go and get an operator here, looking for the multiplies, that one. And we're going to multiply the distance. I'm going to switch it over to centimeters too. By, I think, about 100 works right. We'll see this work. And just copy that variable, plop it in here, and we will download. Let's see what happens. I think you can hear that, right?
Mm-hmm.
Okay. Okay, so no big deal yet. Now, however, most of us run into a wall at some point, and we want to do more than one thing at a time. So let's just say that you had some motors to control or some LEDs to drive, and you wanted those to go on independently. I'll show you a little something here. It's the new processor block, and we're going to put 2 of them in here because I have 2 LEDs. And this is a real waste of resources, but we have them so we could use them. And I have LEDs that are on pin 0 and pin 5. And we want these LEDs to be blinking along on their own without any attention to the other code. So we have red LED, and then we have green LED, sort of like Christmas. All right. And inside of there, we'll put a little loop just to repeat forever. And for those following along in the chat, how's it going? Let us know. I see a bunch of comments streaming in there. Maybe you can read those, Jeff, and let me know if I'm missing anything.
Yeah, good, great, okay.
Oh, you're all so easy. Okay, so one's on pin 0, one is on pin 5. All right, and then we need to put a little pause in there. And the teacher has asked us to do something nearly impossible with a single loop. We want one to blink every 327 milliseconds, and we want the other one to blink, I don't know, what, Jeff, like 330 milliseconds?
That sounds good. Hopefully it'll be visible in the video.
Oh, I think you'll be able to see them. And so now these functions are going to run in their own processor independent of what's going on in this main loop with the repeat. So this becomes really, really handy. And if you want to share variables between the two, you can. Let's just download it. We'll turn that speaker back on. Okay, so right now your LEDs start out blinking at the same rate, but slowly they will start to get off here, and because they're a few milliseconds apart. So I guess 6 seconds for every toggle total. And our sound still works. Now it gets much better than this. You can play WAV files. You can drive motors, all right? And your code stays totally, entirely legible. All right, how'd you guys like that demo? Aside from the BlocklyProp crash in the beginning. Awesome, okay.
Yeah, love it.
It's really the simple stuff that is so fun. Okay, so back to our presentation here. We lost a few minutes there, it's okay. This is another interesting project, and it is a Linefaller. It's a really good example, I think, of just using multiple functions. And this project is fully documented on learn.parallax.com. But basically, your entire code is here. And as you can see, what it does is we check the Linefaller sensors, we calculate the speeds, and then we set the speeds. And this is actually the version before when we add in the color sensor, which would be this version. So then we add in the color sensor. And I think we can just run this and you can see it. So I'll switch my video over to the display. It's a very quick demo. But this is probably so the way this works is green turns around And it's hard for you to see the squares. I'm sorry about that. And then yellow is a right turn, which is that one. Left is red, and then another green. So turn around, then hits red, goes left again. So in this project, it actually is coded like it's a linear stepwise process, but one of the blocks in particular for the color pal does indeed use another processor. It just doesn't start a new processor block. And there's a list of these in our reference guide to show you which commands here actually use another processor, because we can let you run out of code here. There's no feedback to tell you when you've gone too far.
Hey, Ken.
Yes.
Can you switch back to the editor real quick and just click on the code button so they can see the C code that's generated by that?
Yeah, so great, Jeff. Thanks. I missed that. So this is the Blockly code. You click on this and you'll see the C code. And you can copy and paste this into Simple IDE and further edit it there and run it. Once you've changed it, you can't bring it back into Blockly, though. Mm-hmm. And since Jeff pointed that out, if you click on any of these blocks, I really want to draw attention to the reference guide because it's so handy. So I'll just choose this sound block, and it opens the help file for it, and it'll show you how to use it. So one way to learn BlocklyProp is simply to browse all these blocks and see what's possible. And then normally you'll find tutorials that use them on our site.
And don't forget the tiny tutorials.
And tiny tutorials. The YouTube channel is loaded with tiny tutorials from the summer. Yeah. So before we go on, I got a sales pitch for you. The animation kit, which is normally $50 and is shown in this picture as $49, is marked down to $30 for the rest of the day. For your attendance.
Until 8 p.m.
Thanks, Kate. So our marketing people have gone crazy doing this. I don't know how you guys achieved this, but the reason I point this out is because the animation kit is the subject of part of the next couple examples we're going to show you. What's in it? We got motors. These are NeoPixel rings above it. Those are RGB LEDs with 16 million colors. There's a speaker, and there's a PIR sensor, so you could turn whatever it is you're doing on when people get near it. There are also a couple transistors if you want to drive the speaker through that, and a bunch of wires. So go grab your kit today. So yes, it is half off for the rest until 8 p.m. Mm-hmm. Yeah. So I'm going to show you one project, and then we're going to switch over to Carol's stuff. How's our crowd doing out there via chat? You guys still with us?
Yeah.
All right. Yeah, Rich, the speaker, does it sound as good as a VHO? No, it's a lower quality speaker with no amplifier, but it's loud enough. Actually, I'm using it here in the visual metronome, so we'll just show you right now. So I'll tell you briefly about this project, then I want to show you what aspect of the propeller and BlocklyProp is so useful for things like this. This is a visual metronome, and the purpose of it is to give yourself a way to keep time when you play music with something other than a clickety-clacker, although this has sound as well, because I was having trouble getting my clarinet timing down, and I still do. So I turn it on, and it's a little bit hard to see, but there is an OLED, and that OLED shows the current beats per minute, and I think I could just switch over to it with this. Let's see. Okay. So as I change it, right, it shows you the Italian word for the speed, which is currently allegro, or now prestissimo, super fast. Okay. And it has a PIR right here. So that allows this to be on all the time, and only when you walk in the room does it pick up. And then here's a dial for setting the beats per minute, okay? And then underneath each of these light tubes is the LED ring you saw. So this is made with the animation kit. So normally when you set out to make a project like this, your first inclination is to start creating a loop where you think you're in control of the timing, using lots of pauses and pauses that you adjust. However, you quickly find out that certain commands take unknown amounts of time, and you need some way to keep track of the time. This is a feature of the propeller that I found tremendously valuable. So let's get a look at the code really quick. I'm going to start out with it kind of small. Moving things around for a moment. Okay, so in this code, the two things I want to draw your attention to that are very propeller specific is there's a new processor block, and it's running a function called Metronome time. All right, so that starts off another processor that does this function forever. And then the program proceeds to a repeat loop, which runs in the main processor. This repeat loop basically determines where the pot is, the potentiometer, and then calculates a beats per minute, and then displays that information on the OLED. Okay, so let's get a look at the magic though. That happens over in this function, metronome time. And again, this is running in its own processor. And the key commands here, or the key blocks I'm using are this one, the system clock frequency. So what we're able to do here is we can actually check the clock frequency of the propeller as it rolls around forever at 80 megahertz. And then, based on that frequency, use it to measure any elapsed time. And we could wait until that time passes using this wait block. And I've done a few calculations to wait until this value occurs, T-sync, which is actually a portion of the beats per minute. And so there's a system clock. And in the off time, which is the time when the speaker's not on and the LEDs are not being driven, I do everything in this loop. So if you know a little bit about timing, and I've really learned recently, I've been programming microcontrollers sort of for 20 years now. Jeff can attest to that, sort of. I'm not a programmer, so I'm off the hook. You learn that time is everything with programming sooner or later. And if you understand the time base, you could do a lot more stuff. And that's really what I got out of this project. It was so valuable. So it uses the wait until and the system counter blocks to keep track of specific time. And it just makes the whole program like almost nothing too. And I'm sure there are faster ways to write this, but there's the entire BlocklyProp program. And the circuit looks like this. Actually, nope, that's the wrong circuit. Never mind, that's for the spooky doll. That's later. By the way, there's a great tutorial on the timing written by John McPhalen. It's on learn.parallax.com. So he documented those blocks. And how did it turn out with the metronome? I put it in front of my kid, my younger one, and he immediately did this. Let's see if the audio works. So he got it, didn't he?
2 towers instead of 1.
Pretty neat, isn't it?
Yeah,
Did
it is.
it work?
Yeah.
Oh, okay.
Why
Yes, it
you
did.
use 2 towers instead of 1?
Why didn't?
No.
Oh, yeah, I've been asked that question. I've been asked that. I don't know. That's a great question. Yeah, there are a whole bunch of ways to do it, and it could alternate between the towers, as you mentioned. And if yeah, that's really more of a proper metronome. You must play an instrument, do you?
I played the clarinet in high school.
Oh, we got to get together.
I don't know how to play it anymore.
I know what to get you for Christmas. Carol, can you show us your project and talk about them a little bit?
Okay. This was, I actually thought of it before he came out with the animation kit, but I did use animation kit stuff in it. The first one I did was this pumpkin. And these were made, I put them on BowBots simply because I didn't feel like taking one apart to use the PABWX. So I just left it on the BowBot, and I made the little tower here for it. These are 3D printed, And when I write up the instructions for them, I'll put links to where the 3D prints are at for people who do have printers. This one, I wanted to give the effect of a candle being in it. And they're made to put in my window. I put a little black skirt around the Bobot and put it in the window. And this guy here, they look better in the videos than they do on this webcam I've got here. Whoops, I always forget to turn on my speaker. Uh-oh,
Demo time.
the speaker's dead.
Well, we all know how demos go.
Yeah, well, anyway, I wanted it to give the effect of fire in a way. That's why I had it flashing different colors. And that's the nice thing about those NeoPixel rings. There's a lot of things you can do.
Was the speaker being used for wave file playback or?
Yes.
Oh, was it a spooky?
Yes.
Spooky thing? Did you happen to put
probably
that
work
video?
on this guy.
Okay. Are you going to write that up for the Parallax site, Carol?
Yes, both of them.
Oh, we'd love to have those. Those are great. That's a good project.
Kate wants them by tomorrow, so that's what it is.
That Kate, so demanding sometimes.
We're sending out the follow-up, and I just also posted in the chat that all these resources that we're talking about will be captured in email and sent out to attendees and registered participants. So
Okay.
I'll send this. So Carol, get those over to me.
Yeah. This one here I really liked because I ended up cutting up a skull I had printed to make the jaw articulated. So there's a servo under here. And with the BlocklyProp, I was able to play around a lot and get the timing right to make the jaw work in time with the skull noise. Now this doesn't, and then there's LEDs in the jaw and inside the sockets. I made little brackets in there and I put LEDs, the RGB LEDs that Ken has inside each eyeball. And
Also 3D printed, and is it PLA or ABS?
PLA. I only use PLA. So that's, it doesn't look as good on this, but we have a video where it looks a little better.
I'll show that video.
And there again, it's a window display. And I put a black skirt on it to hide all this other stuff.
Nicely done. And I know one viewer right now.
Good in the window.
That looked good. I know that Brian Hickey's going to want to make that. He's got a couple daughters, and yeah, he knows how things work. Here's a video of it, actually. Let's see if we can play it, and I'll set my, whoops. Okay, just a minute here. It takes a few steps. You might be stuck with the small viewing mode. Okay. Did that work out okay?
Yeah, it was short, but sweet. I guess my video wasn't very long.
Did you add LEDs behind the teeth since that video?
There's one right underneath the upper jaw because I wanted the jaw didn't show up in the dark as well. So I had to put an LED down there too. And it actually, the way I've got it now, flashes with the eyes.
You got that skull synced up. And so just so others know, what you did is did you grab the hoo-ha-ha-ha off of some site and then put it into Audacity and then output the format?
Yeah, it was one of the free sites that you can download free WAV files from. And then I put it on the SD card and plugged her in. I had no problem, too. I didn't have to go through... It seemed like earlier on you used to have to go through Simple IDE. Right. And then through putting it on your robot. But for some reason... Maybe because I'd done it before with this board or not, I don't know. I didn't have to go through the Simple IDE part. I just put the WAV file on the SD card, plugged it into the board, and up it came. It worked.
Now, Carol's awfully sweet, and I'm a little bit different, more disturbed than she is, perhaps. So I made this. So I'll share my version of the Halloween.
Can I ask a question on your doll?
Sure.
Since you have the ring NeoPixels in there, don't you?
I do, inside the head.
So why don't you make the eye spin?
Okay.
That's
a
what
great
I would
idea.
do. I'd program it to have those eyes going around, 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 around.
I like your thinking. That'll be the next revision. So this thing kind of works in the same way as Carol's project, and it's written up on learn.parallax.com. It's missing its left arm, unfortunately, from a quadcopter accident, and that happened last year, and its hair is a little bit burnt from a robot that spewed fire in its face. But what was left got turned into this, and we'll see if... Yeah.
Myself.
So it's saying, come and get your meat, I butchered it myself. And this actually uses a really nice feature, the WAV file playback, which is perfect for Halloween. The code for this, it's posted as a tutorial on Learn, so you can go and check it out. There's a video we filmed inside Parallax under a little more controlled setup. Let's see if it works.
I just
thought
posted
of the ketchup in the pocket.
Yeah, the ketchup and the plastic knife. I really don't know why I put the Ozzy Osbourne stuff in there, but the thing was, this was a one-day internal hackathon project at Parallax. So it really couldn't get tuned just right. It just had to get done. So how do you like that one? Is everybody okay after seeing that?
Yeah.
Okay, because definitely more than one child came into the office and alerted me to the fact that this is not the best robot they've seen us make. Specifically, yeah.
They've got high tastes.
Yeah, yeah, they do. They have high
Demanding taste.
standards. We're a wholesome company anyway. So yeah, moving on here, John Harris, that's funny. I could show you also another little project that we did that uses these NeoPixels in another way. And by the way, I think I'll leave it up to you to go look at the code for the spooky doll, and you'll be really surprised how short it truly is. It's 10 lines. And as I mentioned, we had one day, the thing was built in one day and then coded in the last hour. And when it looked good enough, it was done. And that was it, because you can only add so much cost and value to a spooky doll, right? So next project I'll show you is a local high school jazz band where I provided the electronics for them. They had a Disney concert, and I had at least 10 or 15 different things in there, from robotic things that rolled around to lights which were on their music stands. And what I'd like to show you is the lights that were on their music stands. So these use the same LEDs, also called NeoPixels, as the rings are, but they're in a 1 meter format, which I have up here on the wall. And they're activated via RF. So I have a computer sitting over here, and it has on it a XB module just attached to the serial port. And there are, of course, many better ways to do this as well, but this is just one of those things where, okay, you have an evening, go, get it done. And BlocklyProp is really quick at this. So I literally would sit in the audience and turn these LEDs on and off, and they would play different light patterns. So this one is for a Disney intro song, That's red, white, and blue, very difficult to see. And of course, there are a lot of under the sea songs with green and blue, you know, and like Nemo type stuff. And I could just pick a different number, enter it on Parallax serial terminal, and these are all individual receivers. So these are all 10 feet apart in different locations on music stands. All right, and I would just control it from a laptop in the audience, and it had a total of 13 different sequences.
Colors are really brilliant in person, but they're not coming through on the video.
Yeah, that's what I figured.
Well.
So here's a little video that has them. Maybe this will work a little better. I'm going to fast forward to the right spot on this video.
I'm Ken Gracie.
Yeah, we don't need to hear all this. Just
that match their 10 different songs.
We're seeing you, Ken.
Can you hear that okay?
Yeah, but we're seeing your live video.
US 2812 LEDs, and these were connected to their own propeller activity boards and power supply. And then what I was able to do was program each propeller to receive one of 10 commands, and based on the command it would receive, it would activate a different lighting sequence. So how did it work from my position is I just simply had an XP device, that's an XP Pro, okay, and this was all set up in transparent mode. I'm just sending out characters, and all of the music stand propeller activity boards were configured as receivers. So I would use Parallax serial terminal right here, and super simply just come in, type in a command, hit enter, and then that lighting sequence would be transmitted wirelessly to each stand. So
I think you got the idea of this.
And then what I was able to do,
here's a little better picture. Okay, so we'll move on from that. I think you got the idea. Haven't posted the code for this, but in BlocklyProp, there is a block for driving these LEDs. And you can set any of them and put them in sequence and fade them and do whatever you want. It's another short video. Maybe that'll give you a better idea of the color.
We're not seeing the video. We're just.
Oh, you're not seeing it?
Yeah.
Oh, really? I'm sorry, Jeff. It's so interesting because.
Yeah.
Oh, maybe my internet is starting to fade. Okay, do you see the screen now getting started?
Yeah, we can see it.
Okay.
Good. Okay, so how to get started with BlocklyProp. Just a few quick ideas for you here. First off, I recommend getting some hardware. This is one of the cheaper ways to get going. The Try It kit, or you can just get a flip module, which is the star of this board, and then grab some components. I like to go onto Amazon and just buy things that are coming from China. Like there are a lot of inexpensive sensor kits. However, you won't always find documentation for them. So they could be a little bit more difficult to interface, but you could buy this box of parts from Parallax or get a propeller activity board. There's a lot of articles on it. This is one I've written, which you can Google. BlocklyProp has been published number of places. We're seeing it show up in some research papers now, and people are taking it more seriously as a high-level language and less of a cartoon. And I could say with certainty that Parallax has the most capable embedded processing Blockly language out there at this stage, and we're just going to keep progressing it.
Yeah. Hey, Ken.
Yeah.
There's a question from John Harris. How easy is it to control sensors that you don't currently have a block for?
Okay. So if we
just answered that.
Oh, did you? Okay.
Yeah,
well.
that's okay.
Okay. Yeah, and you probably told him, Jeff, about other blocks that.
Yeah, so I'll explain audibly too that if you have sensors that use like an I2C protocol, and we have I2C blocks, you could of course construct the code, the blocks to make that happen. It's pretty easy. Or serial, we have a number of features in. I don't see it there. Is it?
They're right here.
Protocols, yes, that's what I was looking for.
Yeah, so here's asynchronous and synchronous serial, and I think we're getting ready to add I2C.
That's right, yeah, I2C is coming. That's why it came to the top of my mind.
But I also look at this though, the pulse in, PWM, and then the voltage measurement. So here's your A to D converters, PWM for pulses, and pulse in and out for pulse measurement. And the serial blocks are extremely useful. So we have most things covered. And if there's something you want that you don't see, you can go onto our GitHub and make it a request.
Yeah, we're adding blocks quite often. Although it's starting to, the dust is kind of settling now. It seems like we find less and less a need to create a new block.
Yeah, the requests are starting to settle, right?
Yeah.
The tutorials are very good on learn.parallax.com. Some of them are in C and in Blockly, so you could bounce back and forth. And the reference guide is great. Just go peruse it. And it's really like our old printed manuals that people love so much, and they drag them out when we go to different schools and customer locations. It's just all digital and very easy to sort through. And if you're, yeah.
I don't know if it's something you can do or not, but I use the help thing a lot, you know, pop into it to remind myself, how do I use this block, or can I do this with that block or whatever. But a lot of the answers that I'm really looking for are in the Learn tutorials that people have written and in the projects and stuff. It'd be nice if you could put in the help when you jump over to a page that tells you what the blocks do, if you also then maybe have a link that jumps you to the tutorial.
Yeah, so noted. And we have a few where we've started to do that. And that's our goal. You're right. Like you'll see tiny tutorials, I believe, now that are linked up with videos. The way to get to the tutorials is under tutorials, language specific, and then BlocklyProp. And you'll find a list. And this website's about to change. You'll find the formatting at the moment a little bit dated, but not for long. If you're a social media user, come here too. This is a good support group. There are 700 people on it, and Carol's there, I'm there, and we're getting more activity here every day. And then there's also the Parallax forums. And let's see here.
Couple questions.
Yep, let's take the questions now.
Oh, it just keeps on moving. All the chats keep going.
Oh, the question about C.
Yeah, that was, yep. And then there's a Mathematica. John Soper asked, can you make a block for communicating with Mathematica USB port commands? I'm not familiar with it.
Jeff, do you know what that is?
I'm not sure. Is that something like maybe LabVIEW? Perchance, I'm thinking that it is. Maybe John can chime in there. But we could make a block for that. We haven't looked at that in particular, but we do have serial commands. I guess we'd have to know, is Mathematica using, it's a language for doing mathematics and statistics.
We can look into it.
Yeah, we can look into it. It's very likely we can. We haven't really found things that we can't do. Sometimes we think we can't, and then a few days later we realize we really can.
Then there's another question too. Can a PC be used as an output device as well as programming interface via USB? And this is from Sergey. I think what he's asking is like a terminal? Is that possibly it?
Yeah, that's what it sounds like to me.
So a terminal, simple terminal program. Yeah, I'll just give you a quick example right here, as a matter of fact. We'll just...
you had one that showed up on the screen with the graph. There's a graph and a terminal that's available built into the editor.
Here's one example. We'll just plop this distance variable in here.
That's a good idea.
And run that. Is this what you're asking, Serge? Hopefully it is.
It's not just text, please. That's what he was thinking.
Oh, yeah, I think he's asking like a real-time debugger.
We do have a graph as well that allows you to plot things on the screen, X and Y. Not sure if that's what you're looking for.
Yeah, he might be asking about real time. And for output devices, also, Jeff, so I think the most popular ones are the OLED and then still serial LCDs. And right now we're looking into adding an e-ink display, which is a 4-inch,
E-ink.
yeah, e-ink, black on white. Yeah, okay. Are there other questions we could answer? All right. So
he's asking to visualize games. So that immediately made me think of something like Scratch, you know, where you could have like that famous cat walking across the screen. We don't have any kind of output that's like that would do any kind of screen animation currently. Because most of the time you have the applications are physical in nature, where you have a bot or some board with LEDs that are displaying things or moving some kind of motors.
Yeah, we do encounter some interesting questions because most people's use of Blockly and Scratch is starts when they're very young, right? So they're doing screen animation programmings, and then we could put this in front of a group of kids who've never worked with electronics, and they'll say, yeah, I know what I'm doing. I've done this before. But then suddenly it's totally different than what they expect because they have components and much more to work with. So we're definitely seeing like a blurring of the use of this tool at this point.
So Jay also asked of our suggested VGA, perhaps. That's certainly possible with the propeller, as you likely know. I don't think we have an object for it. I mean, a block for it.
I don't think we do, but that's one we may want to add. I'm going to go look here and see if we have one. Intercommunicate. We don't have one for VGA, but that would be easy to add. Yeah, good question.
Yeah.
It looks like Richard has a question.
If you had one for VGA, then I wouldn't have to keep plugging a HDMI terminal into my Raspberry Pi trying to bring the telepresence robot up.
That's true. Yeah, you have the Parallax and you need you'd like to have debugging for the propeller while it's mounted on the Parallax.
Well, what is happening right now with it is I have to remove all the USBs that are part of running the robot in order to plug in a keyboard and a monitor and a mouse and everything to Raspberry Pi to program it to get it online. And then when I take all that stuff off and put all the robotic stuff back into it, it doesn't work. And I can't debug it because I can't get to it without pulling everything off.
For those that don't know, Carol's talking about a robot which is the subject of Make Magazine build on Thursday. And it is a telepresence robot. So it looks like this is the actual kit. And I know that a few viewers here, Roy has one, for example. So this has a camera and a microphone and Wi-Fi on it with the Raspberry Pi, and it's remotely driven through letsrobot.tv's website. And Carol's had one of these online. This is a newer Parallax product, and it, like I said, it's the subject of a live build on Thursday with Make Magazine. It's proving to be very popular. People are quite interested in it. So moving on, don't forget the sale, and of course, you're welcome to come see us. And if we had a little more time, hey, there were a few more things I wanted to show you from a prior webinar, which you can go look up on our website. And while we've been talking about hobby-related stuff, I want to let you know that BlocklyProp can do real-world things too. So this is a robotic boat, which will soon apply the waters of Lake Tahoe and collect temperature samples. And the only thing holding it up is the programmer, which is me, and lack of time. But I've done all the sea trial tests, and this can withstand 3-foot waves. It's actually manufactured by somebody else. But I'm going to do this entirely in Blockly with GPS to show the power of Blockly. This is something we've been working on in the last year. And if you know this area, it's a 20-mile long lake. This boat can run for 14 hours, and it's fully sealed. So it's a challenge. Also done in Blockly. Maybe you've seen Dropcopter. This is a robotic pollination system for almond orchards, and it helps the bees along. And BlocklyProp entirely controls an auger stepper system and the dispensing of this material, which roughly costs $1,000 per kilogram. Yeah, there's a picture of it. So show those to keep you inspired and keep you moving forward on your next projects as well. So yeah, feel free to find those on our YouTube channel and browse them. There's a lot of neat information out there, and it's definitely growing. Well, I want to thank everybody for joining us. And unless we have any more questions, oh, I see. Okay, there was a question about the EEPROM block. Yeah, Jeff answered that, right? There's also SD card blocks we have in demo, which we hope to enable soon. Hey, Rich, how are you doing?
Can
Rich?
you allow him?
Yeah, I just
Actually in production too now.
There he goes.
Can you hear me?
Yeah, we gotcha.
Okay. Yeah, hi. Thank you, everybody. That was really very interesting. Those are super engaging projects. I think the kids would love. So I'm going to start one of them the day after tomorrow. I was wondering, so I've been playing with Blockly at with the middle school kids now for about 1.5 years. And this may be because I'm an old guy and I'm still kind of stuck with paper stuff, you know, handouts and things. But what works well for delivering this material to the kids? Displaying it on the screen and having them follow it? Or do you find that it's best for the kids to keep them engaged, just to be looking at a web page on their laptop so they could get project guidance? Or do you do handouts? Or how do you administer that in the classroom?
Yeah, I can answer that. So the way I have done it in classes is I will show them the pieces they need to use for a project in the first 5 or 10 minutes.
Yeah.
And I'll just show them on my display and have them pay attention.
Mm-hmm.
And show them where the help is and give them the pieces enough that they could actually build it, and then walk away and let them program for the next 45 minutes.
Mm-hmm.
And then see who can get the project working. And then just put yourself in a question answer mode, but encourage them to use the reference and online resources.
Okay.
So I start out by giving them the idea and then the building blocks or the project pieces and walking away, then regrouping them at the end. I found that works pretty well. Kate and I have done that recently with a few classes. Did that work, Kate?
Yeah, no, I think that's really, and that was from one of our prior webinars. I think it was the middle school with Teresa. That's what she was saying too, or maybe it's a prior conversation I had with her, but yes.
Mm-hmm.
I agree with that too. In the courses that I've been in, usually assisting people, there's always a few students that kind of have an ability to excel beyond what the speed of what the teacher is teaching.
That's true.
And so it's nice to present it the way that Ken suggested, because some of them can move on. They could do what he asked, and then they can try some other experiments along the way, and then they inevitably show the other students around them, and
Right.
They get together, teach
One more
each
thing
other.
on that, too. They will inevitably grab all the blocks, just drag them out, and not really give much thought to how things are connected or wired. Okay, because this tends to work with visual programming languages to some extent when you're learning. So really encourage them to build and test subsystems, like engineers. Get one little piece to work at a time, and then go for the next.
Right.
Build in steps. Right, Jeff, from your years on
Yes.
tech support, that's true no matter what programming language you're using.
Absolutely.
Well, I find in the classes I teach that doing the same thing you guys do, let them bang around with it for a while before you start getting into the real teaching part, because if they bang around with it for a while, they have a better idea what you're talking about than if you're just talking about something they've never seen or heard of yet.
Right. Yeah.
How's it going, Rich?
The classes,
Yeah, just in general, the use of it.
really well. The kids love it. I mean, it's colorful and it makes sense. So it's visually appealing and it's organized, and don't have to worry about all the details like curly braces and commas and so forth. So I think the kids can focus on solving the problem rather than details of the syntax. So that's really nice. And I find that they just love building things, and just little things like giving them a spool wire and a pair of wire strippers so they can make their own jumpers. They just love that. And so there's a lot of aspects to this, learning to use tools, collaborating, and learning to program, and learning something about electronics. There's a lot of levels to it. So it's going really well.
There is a perception in some studies I read that Blockly can't be serious because it looks like a cartoon, but that is being put to rest slowly right now by users as they actually use it. They see the capability.
Mm-hmm.
See,
I like it a lot.
All my students are adults, and a lot of them bring some programming and robotics experience with them. And I'm still finding out that once I started showing them the BlocklyProp, they're really going for it. Now everybody wants to buy the activity bots for the classes instead of the other versions of the Bobot. They really like it, and they're getting into it. And these are people who often know other programming languages.
Mm-hmm.
Any other questions, Rich, or from the others? I see like Lawrence LeBranche is here. He's been active on our group. Do other people have projects going on where they need some input or anything else to share about it, your experiences so far? Rich, are you back?
Oh, I'm sorry.
That's okay.
Yeah, I thought you were asking for people, other.
Yeah, if anyone has anything else.
So I was just sitting back waiting for others to respond. No, I'm good, Ken.
Great.
Yeah, I'm really happy with it. That Northwood School, we've made this our core, the core of the program for our after-school STEM club. So it's going very well.
Yeah, well, let us know as you go. I know we've been talking, you've been using it since day one, and always give us your feedback. I know you've had some little bit of surprises here and there when our system went down. This is one of those things we hear about really quickly. If there's a Friday morning and something's not right. Yeah.
It's part of building stuff, right? It's sometimes you got to fix things.
Yeah. Yeah. Well, like Jeff and Jim, I mean, you're looking at the people that fix it. One of them is Jeff, and he mirrors Jim. And there are two of them, but occasionally things go south.
And that's okay. We try to make a learning thing out of that with the kids too, that sometimes you just got to dig into it and fix it, and I think that's a good thing. And the problems we've had have been really minor, just little hiccups here and there, and it's just gone very well.
Great.
No problems.
And there will be an offline version coming. That was due out this fall, but we're running a little bit late. So that's coming. Yeah, Jeff just said 2019.
Well, by 2019, by the end of the year.
Okay. Yeah, we have the pieces for it, and you can actually hack it together from our videos online, but it's not beautiful.
Yeah.
Let's see. Oh. So we'll have to look at the Mathematica a little more. Yeah, so thanks, John. Okay. Well, we'll let everyone get back to their projects. And yeah, have a great Halloween. We have another webinar coming up on Thursday. We're talking to college instructors who are using BlocklyProp. And then we have the Badge WX webinar in early October, both on the Parallax events page. And we'll put all these videos on YouTube too.
I have
Thank-
a request, if I could.
Yeah, Carol.
Anybody out there, all of you, I'm trying to come up with new projects to do that aren't the rehashes of the same old things. You know, just robots that run around not bumping into the furniture. That's been done to death. Robots that go pick something up and put it somewhere else. That's been done to death. I would like to invent or come up with something that's uniquely different.
Mhm.
So if anybody has any ideas, and this can be done with any of the Parallax robots because I have them all.
Mhm.
So if anybody has any ideas, email me with those
Great.
ideas.
Yeah,
Okay.
What
water-based.
I can do.
Here's an idea too. You might want to look at this Quabana's new OpenMV cam. This is a MicroPython programmable camera that identifies colors and locations and faces. And he's been working on these things for 15 years. And I've got a few of these on their way to Parallax, and we will be carrying this. And I hope to integrate this into Blockly.
Oh.
And that reminds me, Ken, I'm going to do something with your Color Pal maze. I'm working on turning it into a maze solving game for Robothon. Because I think the idea of, you know, we've done line maze to death for years and years and years and years, and a lot of people have it pretty down pat. But by throwing the Color Pal in there with the colored blocks, adds a new dimension to it.
Yeah, I thought you had posted the final challenge when I saw the retrieve the beer from the refrigerator large robot competition.
Oh, I love
That's
that.
difficult.
It's very difficult. But that was because Robo Magellan now is getting easier and easier for people to do over the years. It used to be the really big challenge. So
Wow.
we had to come up with something new to challenge our top level robotists and programmers in that. So
Yeah, I agree. Yeah, I'm in the same boat as you. For me, I think I want to do outdoor robotics with GPS. But I think vision and what you're doing with the telepresence robot are of interest to a lot of people with robotics, and that certainly isn't bouncing off walls.
well, in the telepresence robot, I'm designing one of my own. This is one of the first pieces I printed for it.
Oh, nicely done.
I'm doing yours and I'm doing one of my own also.
But when you get into those kinds of robots, you're combining lots of systems. It gets hard to figure out why things don't work sometimes too.
Oh yeah, definitely.
But we've enjoyed watching you get the Parallaxy rolling.
It's almost there. I had the camera working yesterday. The camera was working on Let's Robot. But then when I unplugged everything and put all the drive systems back on, it quit working.
One of the viewers just posted that he's going to design a bicycle wheel truing stand which will gather data and have some control. So that's a great application. Very real world, I would say. And we'd like to have that, John, when you finish that and you write it up. That'd be a great project for our website, and we'll send you hardware in exchange for sure.
I work for robot parts.
Yeah, hopefully others do too. Okay, well, everybody have a wonderful evening. Thank you so much.
Thank you.
All right, bye now.
Bye.
Okay, bye everybody.
Bye.
Bye.